You ever wondered what the difference is between a single thread, a multi-thread, in terms of one process, and how that maps or is different to things like service orchestrations and service choreographies? Well, if that's the case, then you're in the right place. We're going to look at that and give some examples that might help you grasp the differences. A single-threaded process is very much like somebody playing a single instrument and playing a piece of music from end to end. This is a relatively simple way of writing code, and it's where most people start. Multi-threading starts to add a little bit of depth, though that does not come without complexity. Multi-threading is like one person playing multiple instruments simultaneously. It does allow a bit more depth to the performance, but it doesn't necessarily help completely with scaling it. Where you're using multi-threading, you are constrained still by the resources on that machine. You can scale vertically by adding more horsepower, more CPU, more memory. But ultimately, there's going to be a limit to that. A service orchestration is pretty much like an orchestra, where you have lots of independent actors, i.e. processes, but they're all dependent for their commands and timing on a single process. In an orchestra, that's the conductor. You can scale pretty dynamically, but you're always dependent on that single orchestration process. The conductor is there to make sure everything happens in the right order, everybody knows what they're doing, and things get passed around in the right way. If they're not there, the whole transaction doesn't happen. It also handles any errors and any rolling back of transactions. It's a little bit more complicated in terms of a service orchestration because you've actually got two conductors, one that's looking after the transaction side of things and one that's looking after making sure everybody in the orchestra turned up. That is, if a process dies, you get somebody goes offline, they're replaced, you spin up a new version of them. This doesn't tend to happen in an actual orchestra. We don't see the violinist keel over and they just wheel another one in his place. If you're finding this video useful so far, then please click the like button. Service choreography is probably the hardest one of these to get right. The depth involved is very similar to that of an orchestration. You can scale individual parts. But the key difference is they are absolutely independent parts. They all have to understand how to deal with errors, how to catch up, how to communicate and flag that something's gone wrong. This is very much like a really tight duet. Small timing issues are communicated seamlessly. If either of the two make a mistake, they will correct and bring themselves back up to speed. This means you get a seamless end-to-end performance, and nobody watching it would be any the wiser that anything went wrong. In a choreography, managing the rollback of a transaction can be quite complex because multiple services will have been involved. They all need to be signaled and roll back their part of the transaction. This tends to happen in a slightly different way. Rather than rolling back a transaction, you'll often find they have a reversal forward transaction. Getting this kind of process choreography wrong can result in something that is incredibly fragile, but getting it right can build something that is almost indestructible, infinitely scalable, and incredibly dynamic. Why not try this video out next?